Hello, welcome to my lightning talk on approval tests. My name is David Kane and I work at GDIT. I wear a number of hats there. Sometimes I'm an agile coach and trainer. Sometimes I'm a solution architect. Today's story is from the perspective of leading a software development team. The team I was working with had a PHP application that performed HR functions, and it had been very successful. It had been adopted by the client's organization. It had been adopted by many of their peers, but there have been some problems with stability, and they wanted to reduce the technical debt. The problem was that there was not very good unit test coverage, only about 6%, and this overstated the coverage because many of the tests were not very good. Many took the form of interact with the system and check to see if an object was null. So there are many ways that you could introduce errors into the code base without tests detecting them. So we had this chicken and an egg problem. How do we refactor the system without good test coverage? How can we add new unit tests without refactoring the system? And to do that, we turned to a framework created by Llewellyn and Falco called approval tests. And the key metaphor of the system is the idea of a snapshot. You would interact with the system in some way, try to capture that interaction as a file, then you could interact with the system again later, compare the two files. If the files matched, the test would pass. And if they were different, you would have to take some action, either fixing the code or modifying the test reference. This kind of model, has now been incorporated into many other test frameworks, which I think speaks to the usefulness of the approach. So to see an example of this, imagine a receipt system here. First time we run this, we don't have a reference file, so we have to inspect the output to see if it is what we want to see from the system. And if it is correct, then we use this as our reference. Subsequently, when we run the same code, if they're the same, we'll simply get a report that our test passed. But if they're different, we can see the changes here. And in this case, we actually have both a bug and a new feature. Lego has some expensive models, but none of them are up to $5,000 yet. So we can fix that bug. And now we see the other difference, which is really about this new feature. Once again, we can inspect this, see if this is what we expect to see, and then update our reference accordingly. One of the things I like about this approach is that it pushes the expected behavior into an external file, so the test code itself is very clean. If we compare this to what our traditional assertion-based model would look like, we see that there's all sorts of different kinds of assertion statements here. I think it's harder to share with business and product stakeholders, and so this is one advantage of this particular approach. When doing this, it can be useful to identify where the seams in your application are, as Michael Feathers points out in his book. In our case, we were using JSON interfaces that our application already had. Sometimes you can see command line or reporting interfaces as other ways we can use to find seams without modifying the code to inject these kinds of tests. Sometimes, as we look at our reference and our test result, we can inspect them to say if they're in fact the same, which is in essence what the snapshot is doing. But sometimes we see differences, but we may not necessarily care about them. So in this particular case, our JSON objects included date timestamps that were going to change every time we ran, but we didn't really care about those differences. So what we would do is we would strip those out prior to saving our reference files. Using this approach, we were able to get up to 65% test coverage, all while continuing to develop new features and reducing technical debt. Our customer is much happier with the outcome. The system is still in operation, and we were able to get some other opportunities to do software development with the same customer. I'd like to thank Llewellyn and Falco for creating the framework, George Paci for helping me with the original version of this talk, and my son Avery helped create a number of the models here. You can find more information about the frameworks that we use for this at those URLs, and you can find me at the links below. Enjoy the rest of the conference.